Okay, in this video we're going to be looking at logs of different bases and ln and just kind of what's different between them and what's the same, kind of so that you can distinguish between logs and ln's, like where do you use them, how do they show up. And so really I'm going to start really vague here just with log. When you have log base b of x, right? That is the inverse of b raised to the x power, right? These are the inverse functions of each other. They undo each other. So for instance, if you have log base 2 of x, that is the inverse of 2 to the x, right? These two are inverse functions of each other. Okay? So how is that useful? Well, if you have equations and you want to try and solve for x, you can use these two to undo each other. Okay? Essentially, whenever you do 2 raised to the log base 2 of x, whenever you replace x in this one with this function here, you do 2 raised to the log base 2 of x, they undo each other. They cancel each other out and you just get x. Okay. Also, if you do log base 2 of 2 to the x, so if you replace x in your log with 2 to the x, well, you just get x again, okay? They undo each other, okay? So how is this helpful? An example where it might be helpful is, let's say we want to solve for x in an equation like this. So let's say I've got 2 to the 3x plus 1 is equal to 7, okay? And I want to try and solve for x in this, okay? So how is it that I can solve for x in this? Well, if I want to get x out of the exponent here, what I want to do is I want to take a log of both sides. To undo the exponential, I need to use a log. So I'm going to do, and the inverse of 2 raised to a power is log base 2. So I'm going to do log base 2 on both sides. Okay. So when I do log base 2 on both sides, these cancel out. We just get 3x plus 1 is equal to log base 2 of 7, right? And so now I can solve for x, right? I could subtract 1 from both sides and then divide by 3 on both sides to get my answer. So 3x would be equal to log base 2 of 7 minus 1. And then we would just divide by 3 on both sides. Okay, so that would be my answer for x in that situation. Okay, so that's one way you could get rid of a 2 raised to the power to get x out of the exponent. What happens, per se, if instead of having 2 raised to the power of something, let's say, what if I had log base 2 of like 4x minus 2 or something like this is equal to, I don't know, I'm going to put 0 here. Okay? How would I do that? Solve for x again. Well, in this case, I want to get rid of the log base 2. So, again, like log base 2 and 2 to the x are inverses of each other. So how we get rid of log base 2 is we raise both sides as the exponent of 2, right? When you plug that log base 2 in to the exponent, these cancel. These undo each other. So you just get 4x minus 2 there. 4x minus 2 is equal to 2 to the 0 power. So we get 4x minus 2. 2 to the 0 power is 1, and now I could solve for x. This is just a linear equation. I would add 2 on both sides. Get 4x is equal to 3, and then I would divide by 4. So x would be 3/4 in this instance, okay? So that's how you use logarithms, right? Logs and exponentials undo each other. When you plug the log into the exponent, they cancel out. And if you do a log of an exponential expression, like a log base 2 of 2 to the x, those undo each other as well. Okay, so that's kind of the big thing you need to know about logs and exponentials is they undo each other. Okay, so how do like log without a base written on it and an ln fit into this? Well, essentially, log without a base on it and ln are just examples of some logarithms. So log of x, okay, when we don't write something on the base here, the base that we're meaning, the standard base for log, is base 10. Okay, so really what we mean when we write log without something down here, that just means log base 10. It's the exact same thing. Okay, so in other words, log of x, this is the inverse of 10 to the x power, right? So these are inverses of each other. Log without an exponent undoes the 10 to the x stuff. So for instance, you would use log if you had an equation like 10 to the 2x minus 1 or something, and you want that to equal 3. I don't know. I'm just making stuff up. If I have an equation like this and I want to solve for x in it, I would want to get rid of this 10 raised to the power, right? So I want to move x out of the exponent. We're going to use a log base 10. Now, you can always write base 10 if you want to, but just the standard convention is we don't write the base for base 10. So I would just take log of both sides of this. Log and 10 to the x are inverses of each other, so these cancel out. We just get 2x minus 1 is log, really, base 10 of 3, right? And now I could solve for x, right? I'm going to add 1 to both sides. So we get log of 3 plus 1, and then we could divide by 2 on both sides to get x alone. This would be our answer, okay? So really, log where there's not a base is just another example of a logarithm. It's just base 10. So whenever you want to get rid of 10 to the x's, you're going to use log. I guess I should mention too, if you had an equation with log in it, so just log of, I don't know, 4x plus 5 is equal to 3 over here. I don't know. 3 is probably too big. Maybe I'll just do 1 over here. Log of 4x plus 5 is equal to 1. Well, how do you get rid of this log? You get rid of the log by raising it as an exponent, right? And what do you raise it to? Well, it's the base, right, that it is, and it's 10. So we do 10. We raise both sides as an exponent of 10. Now these cancel out, and we get 4x plus 5 is equal to 10. And now I can solve for x, right? So I could subtract 5 from both sides. We get 4x is equal to 5. Divide by 4 on both sides. So we get x is like 5/4 there. Okay. So in other words, just log and 10 to the x are inverses of each other. When you don't write a base, the base is 10. Okay? So ln is another example of this. it's just another example of a logarithm, okay? And it's a little bit, I guess, it has the tendency to confuse people because the notation looks a little bit different, but it's the exact same as what we just did, just with a different base, okay? So let's look at ln now. ln of x, okay, this is also just a particular log. It means log base e of x, okay? And you're probably like, well, what is e? E is a number, and it's kind of like pi in that it's a really long decimal, but the number e is like 2.71, and it keeps going on forever. But that's what e means in math, okay? It's like a number that's 2.71, and on and on and on. And it shows up in a lot of applications, so that's why we gave it a name of e, okay? So really, ln is just another example of an inverse function to an exponential function. Ln is the inverse of the function e to the x. Okay, though ln and e to the x undo each other. Okay, so in other words, you want to use ln if you're trying to get rid of an exponent where the x is raised as an exponent of e. So for instance, if you add e to the 4x minus 2 is equal to 7, how do you get the x out of the exponent? Well, you need to use a log. To undo an exponential, you use a log. Well, the base of that log is going to be e, so log base e is ln. That's just the notation we use for it. So we just take an ln on both sides. ln and e to the x, right, cancel out. So these undo each other. We get 4x minus 2 is ln of 7. And now I can solve for x. Add 2 on both sides. So we get ln of 7 plus 2, and now divide by 4. Okay, so there's our value for x. Okay, so in other words, ln and e to the x, these are opposites. And so if for instance as well, you had a equation with ln in it, like ln of 2x minus 7 is equal to 4, you're going to use e to solve for x, right? How do you get rid of that ln? Well, you get rid of it with an e. So you raise it as an exponent of e on both sides. These now cancel out. So you get 2x minus 7 is e to the 4th power. And now you could solve for x. So plus 7. So you get 2x is e to the 4th plus 7. And then divide by 2. Okay. Now, sometimes the equations you have to solve are a little bit more complicated than the ones I've been doing. But essentially, you just want to get rid of either your log or get the x out of the exponent. So if you have a log, to get rid of it, you raise it as an exponent. If you have an exponent, you get rid of it with a log. They undo each other, okay? So just ln and log are particular examples of logarithms. Log without a base is base 10. Ln is just log base e, okay? They are particular examples of logs. Now, you can't, you're always just going to use whatever log you need to solve the equation. So, for instance, if you had 7 to the 2x plus 2 is equal to 8 or something like this, how are you going to get rid of this so that you can solve for the x? Well, you're going to use a log base 7, right? Because that's the thing that's the base here below the x power. So you're going to take log base 7. So in that case, you're not going to need ln or log, but you're going to need log base 7. Okay, you only use log without a base written when you have like 10 raised to the 4x, because log is log base 10, right? You only use ln if you have e to the e raised to some power, right? That's what you're going to be doing there. So hopefully that kind of helps you see ln and log without anything written below it, without a base. These are just particular examples of logarithms. You just use them when you want to get rid of an e to the x or a 10 to the x, like when you want to solve for x. And if you want to get rid of a log, you're going to raise it as an exponent of 10. If you want to get rid of an ln, you raise it as an exponent of e. Okay, so hopefully that kind of helps you see how we use logarithms and ln's with the different bases. I hope that helps. Let me know if you have any other questions. I will see you later.